Assalamualaikum warahmatullahi wabarakatuh. And hello everyone. My name is Amirul Farhan bin Amran. We are from University Kuala Lumpur, Malaysian Spanish Institute. And today we will present the updated version of our mini project for the electronic instrumentation subject. So this video shows our progress for this week. During the previous week, our main focus was just connecting the hardware. Basically, test whether the components could power up and respond. At that point, our setup was not organized yet and the pin connections were not properly arranged. So for this week, we continue with the testing phase and made several improvements. So first, we test and adjust the pin connection for the MQ135, DHT22 and LCD I2C. So these pin assigned are not final, but they are our current working setup. For the second, we use the serial monitor to observe live sensor data, including raw voltage from MQ135 and temperature, humidity from DHT22. We perform basic sensor calibration checks, especially verifying the MQ135 voltage response and confirming that the DHT22 reading are stable. And lastly, we also clean up and arrange the circuit so that is more stable and easier to troubleshoot compared to last week. With this update, our system can now display temperature, humidity and MQ135 voltage on the LCD I2C while also showing detailed reading through the serial monitor. Next, we will explain the updated circuit and how each component work together. Let's go. Hi, my name is Amir Farhan. So let's continue to the circuit explanation.
Our hardware setup use three main components connect to ASP32, the MQ135 gas sensor and DHT22 temperature and humidity sensor. Also, we use the I2C LCD display. So the MQ135 is connected to the ASP32 through the D34 analog input pin. And then the ASP32 convert the analog output from the sensor into numerical values which represent gas concentration level. The LCD use I2C communication which only requires 2 wires, SDA to D21 pin and SCL to D22 pin. The LCD displays 3 key value which is temperature in Celsius, humidity and percentage, and voltage from MQ135 analog input converted. I will be performing a functional test of our environmental and monitoring circuit. The system used 3 main components connected to an ESP32 microcontroller, MQ135 gas sensor, DHT22 temperature humidity sensor, and I2C LCD display. This test will confirm that each component is working properly and that the ESP32 can read, process and display real-time data. To safely test the MQ135 sensor, I will use a lighter without igniting it. Simply pressing a lighter release a small amount of button gas which the MQ135 can easily detect. Watch the LED, the MQ voltage should spike as the sensor detects the gas. As expected, the MQ135 voltage increased significantly. This confirms that the sensor and the analog readings pin D34 are functioning correctly. Next, I will test the DHT22 sensor, which is temperature and humidity sensor. Look at LCD, the temperature increase. This demonstration, we confirm that the MQ135 sensor responds correctly to gas, and then the analog voltage reading on pin D34 is functioning. Also, the DHT22 sensor is giving accurate temperature and humidity value. After that, the I2C LCD display is properly showing all 3 measurements. And lastly, the ASP32 is successfully processing and updating real-time data. This completes an functional test of our circuit.
That's all from me. Thank you.
Assalamualaikum. My name is Farah Hanim, and I am going to explain to you about this sensor MQ135. The MQ135 gas sensor is designed to detect several indoor pollutants such as ammonia, benzene, alcohol vapors, and carbon dioxide. The sensor works by changing its internal resistance depending on the amount of gas in the air. This resistance is converted into an analog voltage which the ESP32 reads through the D34 pin. However, this sensor is very sensitive to environmental conditions. Temperature and humidity changes can affect its voltage output even if gas levels remain the same. Because of this, the MQ135 alone cannot give consistent readings. That is why we combine it with another sensor for better stability.
Hello, my name is Aina Farisya. So I'm going to explain about DHT22. So the DHT22 sensor measures two important parameters, which is temperature and humidity. These values are essential because both temperature and humidity influence the MQ135 sensor's behavior. Next is sensor fusion for DHT22. In our testing phase, the ESP32 combines data from both sensors. The DHT22 readings help us understand how the environment affects the MQ135 voltage. This simple fusion approach improves the stability of our air quality testing and gives us a more meaningful interpretation of the gas sensor's raw voltage. Later, the fused data can be uploaded to ThinkSpeak for real-time monitoring, but at this stage, we are focusing on stable readings through the serial monitor at LCD.
Hi, my name is Izzat. Now I will talk about the LCD display and output. To make our testing easier, we integrate an I2C LCD display. This LCD currently shows three main values. First is temperature, and the values is Celsius. For humidity is percent, and for MQ135 voltage, raw analog value. By monitoring the voltage, we can check whether the MQ135 is warming up properly and responding to exchange the LCD update continuously, allowing us to observe the sensor behavior in real time without connecting a laptop. At the same time, the serial monitor show more detailed raw data which is useful for debugging and calibration. That's all for me.
Hi, my name is Amir Sharifullah. In conclusion, this is our updated progress for this week. We have improved our circuit arrangement, test the pin connection, use the serial monitor for debugging, and perform initial calibration for both the MQ135 and the DHT22 sensor. Our system can now display temperature, humidity, and sensor voltage through the LCD and serial monitor. This improvement helps us understand the behavior of the sensor before moving to the next stage of the project. Thank you for watching our updated mini project demonstration. For the next update, stay tuned.